And very welcome to the research seminar today. This particular session is dedicated to doctoral students, those who have presented the research proposal in the previous semester. So we have 2 students today. Next session, next lecture, next Friday, we're going to have other 3 students. So we're going to start with Karen Cristina Sujo Contla. She is a student of the 3rd semester in the doctoral program in computer science, and her supervisor is Dr. Neil Hernandez. So she can have, since we have only 2 lecturers today, so we can have 15 minutes for the presentation, even a little bit more. And the second presentation is by Luis Ángel Márquez Vega, and he's supervised by Dr. Edgar Covantes Osuna. So Karen in particular is going to talk about a methodology for immunization supply chain through data science. So you can share your presentation, Karen, and you can start anytime. Okay, thank you very much for being here today.
Okay, hello everyone. So I'm Karen, I'm a 3rd semester student, and today I'm going to discuss the immunization supply chain. My agenda for today is to describe the current problem and how I got to where I'm at. The second part would be presenting my current hypothesis, the general objective, state of the art, and my work plan and methodology. So for my problem description, first I started looking at supply chains. Actually, I first started looking at the cold chain for food distribution, but then I became more passionate about the healthcare sector. So what is a supply chain? It's a series of steps for the movement of goods or products or even services. And they are managed by logistics. And in my case in particular, they are called humanitarian supply chains. So they focus on humanitarian operations. So we know there are like many challenges. First of all is that we have like to optimize like the costs. So it's how do you measure effectiveness? And then we want to know also what the role of data science is. There are things we don't know. So it's how do we model a behavior to generate a methodology? And well, what's the better way to improve response time? So there are currently several challenges. So for the methodology, it's that most research is focused on commercial cases. So like they will be looking at mainly how to optimize cost. But for humanitarian supply chains, maybe like cost is not so important as is like, for example, after an earthquake, saving a human life. So regardless of the cost, you're going like to prioritize how that works. Also that there is a lack of collaboration between stakeholders. For example, for medicines, you have to manage counterfeits, the shortages, because like maybe like people may fight for some good or supply, for example, food after a natural disaster. So the supply chains have to be resilient. There's also the risk that they cannot be forecasted. So for example, if you were managing a company, you know that there's gonna be a demand for toys in Christmas, but you cannot predict like when like natural disaster will happen unless it's like a meteorological event. But for example, the pandemic unfolded like very quickly, so there was like not enough time to supply and like adapt the supply chain, for example, for the distribution of face masks and such. So that's why that's why we know humanitarian supply chains need to be agile and resilient. So we also need to focus on collaborative risk management. And also there is the issue of inventory, because sometimes it cannot be optimized. So for instance, we know that we have like the Pfizer vaccine and it was like being withheld in super cold temperatures, but there are regions where that is not available. So you have to plan like how long is it going to take to be delivered on the last mile, and well, examples like that. And also the specific problem, at least in Mexico, is that there is an information deficit. So like there are inventory asymmetries because of the lack of like IT and databases that are currently updated. So I conducted a SWOT analysis, and for this research in particular, I found that the strengths are that we have experience from the past in recent epidemics. So mainly I'm basing a lot of my methodology on the H1N1 flu pandemic. There are solid data-driven methods. So like we have the theoretical foundation and it's kind of recent, so it can be used. Also for this research in particular, we have like the emergence of big data and high computational power, which was like not available in the past. The weakness for this research is that there are not many interdisciplinary groups. So for example, like the medical sector is working on one thing and the decision makers and politicians are working on another. So yeah, it's kind of hard to make them collaborate. And there are time constraints because there is not always a fast academic response. So like many things are being done on hindsight, or for example, for other like diseases, like let me think, like dengue, there is like not enough information about it. So yeah. And so for threats, I have the possible reduction of data transparency. So like currently in Mexico, we have the benefit that government data is like transparent and public, but if the policy changes, that could be like a threat. I hope it doesn't change. Some data sets are inconsistent. There is a difficult transference of result, and there is like not fast validation between the academy and the research. The current opportunities are the applicability of data-driven forecasting, the international coordination, open data from other countries, and public and funding and private funding. So my hypothesis is that a data science approach can be useful for designing a model that allows us to explain retrospective situations and predict whether better decision-making can be applied on the humanitarian supply chains. So I will be using explanatory and predictive models to create a methodology that aims to improve the health outcome and prioritize social equity. And what I mean that is that like the most vulnerable groups, despite the kind of disease, are prioritized. So for example, for COVID, it would be like the old, and for example, we know that people who are more at risk are people who have to like engage in more like social interaction. So it's always different for always kinds of groups. So that's why the term of social equity is very important. And the general objectives is like, well, designing the humanitarian logistics methodology. For my thesis, I will be working on the COVID case, but it should apply for all Mexican immunization supply chains. So the first thing I did, and what I'm finishing right now, is reviewing the existing framework, logistic management and geospatial information. By geospatial information, I mean that I am looking at how long the distribution channel is in terms of distance. So I'm also like, for example, considering looking at satellite imagery to see like where the population clusters are, but it's still in the works. I'm also reviewing the theoretical framework, so about previous outbreaks. Like I mentioned, the one that I'm using the most right now is influenza, but I'm also looking at cases of dengue in Yucatan, so how the vaccination efforts were conducted. I'm also currently looking for more databases to enrich my research, and for the data science framework and models for logistics. So my third part will be to narrow down these aspects, which I'm also like currently working on this semester, and to develop a methodology, which will be using the mapping services for the geospatial information, like I mentioned. I'm also looking at demand forecasting. So for that, I am looking at how to use digital epidemiology to forecast like where the outbreaks are going to be and when. And also measure the impact capacity of medical centers, evaluate risk. And my last step, hopefully in the next semesters, would be to apply the methodology to COVID-19. The state of the art. Well, these are some of the papers I looked at, but the ones that I like found most useful is how data science applications are used like for Indian agriculture, like to reduce food waste. Also how the influenza pandemic like was used to design a better supply chain to distribute food to vulnerable populations. And then after that, they started looking at how to distribute vaccines. And the other one that I have found super useful is this one. It's very recent. So they model a vaccine allocation in the COVID-19 pandemic in Australia. So most of what these studies have done is like forecast demand, and then based on that, like decide which the best distribution centers are going to be. So my research questions are, which are the main challenges? How can effectiveness be measured? Like if can data science be used to explain and predict the behavior of the humanitarian supply chains? And if this can serve like the generation of a methodology, and whether the methodology that I design can improve the time to distribute the necessary elements in the humanitarian supply chain. So if we were like to narrow them down, they are supply chains, humanitarian supply chains, and the immunization supply chain is part of a humanitarian supply chain, but it's like a special and separate field because it has like very specific characteristics. So in general, like supply chains like have the scope that evaluate performance. They have like a function which should be agility and resilience. So they evaluate causal relationships. So the main tool is agility. And for the measurement, it's resilience, like how can they adapt or bounce back. And the plan for implementation considers like both scopes, and it defines the interaction of stakeholders. So I'm not gonna go like very deep into this, but it's like how the stakeholders interact. And well, I am just like going to mention who the stakeholders in this research are. So part it's the government, which includes sanitary authorities, healthcare, and public healthcare. And their role is like to create program awareness, open discussion, ensure accessibility. The academic, which includes universities and research centers. So their role would be like to promote innovation, develop the vaccines, contribute to the logistic challenges, etc. The medical sector includes docs, nurses, pharma companies, and many others. So their role is to like provide the services and the education. And the media, which is like guiding the opinions. And the general public, which is the population who's going to receive like a vaccine. So for the current epidemics, we conducted research on the opinion of the media regarding the vaccination strategy. So what I did is like scrape the web for like the opinion sector of these 5 newspapers, which are the most important in the country, according to the Alexa national ranking. And the reason why I looked at the opinion column is because by essence, journalism should be like non-biased. So this is where I could find like the most opinionated or well biased like opinion regarding the strategy. So this is a number of total articles analyzed. And so I measured different emotions, which were like sadness, anger, or fear. So I categorized them as negative emotions. Then for positive emotions, I looked at happiness and trust. And for other emotions, I consider like surprise, because a surprise can be either good or bad. And regarding the timeline, since the announcement of the vaccine, which is February until March, this is like how the opinion like fluctuated. There's not a clear pattern, but what we could see is that negative emotions like were the predominant ones regarding the vaccination strategy. And also like clustering them between negative and positive. This is how we saw that each newspaper behaved. And it's interesting because, for example, Excelsior should be like the more left wing and the one like is more close to the current political ideology. It's still like, it's not very evident that it's very positive. It's like 50-40, 50-50 and stuff like that. So after looking at this, I would like to discuss the state of the immunization supply chain and why it's like a whole supply chain on its own. And it's mainly because vaccines are biological substances, so their effectiveness depends on the supply chain. They have to maintain an average temperature, which is different, but most of them are between 2 and 8 Celsius. And yeah, well, it also relies on the cold chain equipment, which can be like from ice trays to super technological and super cold refrigerators. And the main challenges are vaccine wastage, which is what I'm looking to reduce with this methodology. Vaccine wastage can be caused by human errors, by the failure of cold chain equipment, and by accidental freezing. So that renders like the vaccine useless, and it's like a problem because the government like already spent money on that substance. So we're like looking how to reduce waste. And the role of data in this is used for tracking, forecasting, and optimization. So the specific challenges within Mexico is that technology is hindering the application of, for example, blockchain. It would be super useful to use blockchain on knowing like when the vaccine came out of the laboratory and that it's like the one being applied to the final user. I think that would like increase the amount of trust the public has on the vaccines. Also like the Internet of Things, because we don't have that right now, and it could be like also very useful. And well, this is to ensure its optimal status. And regarding the last mile, which is like after a vaccine arrives to a distribution center and like it then goes like to a small town or a clinic or a pharmacy. So that's like the most costly part of the whole journey and supply chain. So there are like different options, which is thermostability. This means like the vaccine is formulated so that it can last like definite amount of time outside the cold chain. So for example, it can be like 4 hours at room temperature or stuff like that. There are also like technical hurdles, like how are we going to get it to the public? So for example, in rural areas, like you get the vaccine to a clinic and then you have like to travel super fast in a motorcycle to get to a specific town. And also the fact that vulnerable populations are scarce. So it's not like we have, for example, for COVID, a cluster of old people just in one space. They are scattered all around the country. And the fact that there are a limited number of vehicles. So for example, right now we're getting the COVID vaccine on airplanes, and then like the military is handling like a lot of the logistics, but for other vaccines like rotavirus or stuff like that, they are like managed by private entities. So they also have like their own logistics equipment. So the considerations are working on the forecast spread of COVID vaccine. So for this, I am using the spread of influenza, which is like a very similar disease. The geographic variables, because for example, weather can change in a region and that can affect the lifespan of a vaccine. Longitude and latitude. Also for demographic considerations, it's age, population density, compromising conditions. So for example, if you are delivering food like Rappi or Uber, like they are like more vulnerable, even if they are like young population, which should not be affected the same like a virus. Also like field of work, for example, nurses are at a higher stake, or teachers, and also regional connectivity. So how you get things includes like traffic patterns at a certain time of the day, the availability of flights, which was like a big challenge during the early stages of this pandemic, cargo and road infrastructure. So for example, there may be trenches where like somebody needs to travel by bike. And currently there was an existing tool, but it's unavailable right now. It was called Hermes, and it's the acronym for Highly Extensible Resource Modeling Event-Driven Supply Chains. So this was a tool designed by the Supercomputer Center of Pittsburgh in collaboration with Carnegie Mellon and University of Pittsburgh and Johns Hopkins University. And like it was a tool that helped you like measure or predict the cost of a supply chain. So I'm looking if I can propose like a better methodology to challenge. For example, this was designed for first world countries. So for the specific case of Mexico, we might need something else. And this is my work plan. So currently I'm finishing the goal definition and currently in the process of submitting an article. Then I will be working on acquiring data, cleaning data, enriching data, finding insights, working on visualization, deploying machine learning if I can use it, iterate and tuning the model, and then like closing the results. So I think that's all. This semester I'm working like really hard on the methodology because I have not like defined it well. So as I mentioned, I still don't know if I'm using like satellite imaging for this or if I'm using digital epidemics. So it will be carried out soon. And yeah, that's all. Thank you.
Okay, thank you very much, Karen, for the presentation. I think we can take some few minutes, to have questions. I don't know if there's any question from the audience for Karen, please. Or we can save them for later.
I think we have one from Leonardo.
All right, yes.
How I'm going to measure the improvement of the supply chain. Well, forgive my cat. I don't know. So the factors that I'm looking at are cost and reducing time. So those are like the main priorities for healthcare. Like if the government knows that like something is less costly, they will likely invest in that. It shouldn't be like a factor because like healthcare should be the priority, but the fact is that I will be looking at cost.
Okay. What do you think about you're proposing a methodology, right? And then probably you were mentioning behavior, right? You're trying to predict some behavior in the supply chains or the kind of supply chains that you have. And a mathematical model could be also an option to do this. What do you think about that? What's the difference or the advantage that you have if you're proposing a methodology instead of a mathematical model? What would you think that the advantage is?
Well,
with your approach.
I'm looking at using mathematical models because like currently the healthcare sector has like ways of predicting a pandemic. So like there's like the traditional way of doing it, but the like recent things that I have found this semester, and the reason that's it's not included in my presentation, is that Google Trends is being used like to forecast outbreaks. So for example, it's the queries users make on Google to know like the symptoms, no? So like sometimes you research headache, fever, and you get like the result like, oh, you have cancer, welcome to Google. So people actually look for their symptoms, and so it's like a new field of research that I think I'm going to get involved in for my thesis.
Okay. You muted your microphone.
My cat muted me, sorry.
All right, yes.
Okay, no, so what I was saying is that so users like look for their symptoms on the web, like to get like a treatment or like know what they're going to tell the doctor. So I'm probably going to scrap the data for regions in Mexico and look like whether they are searching for a certain disease symptoms before it is actually like a big deal. And that is currently being used for other diseases. One is influenza, and it was used in the US for military populations. And the other option, which is also new to epidemics, because like they found that Google Trends can better predict a forecast, but it's also like really dependent on the media coverage, is that they are looking at social media to see like what people are tweeting, the kind of like language they're using, syntax, to see like how the disease spreads in a region. So it's also geospatial, and they focus on like encrypting to make sure that it's, well, anonymous, but it's also like used for forecasting. So I'm like using the traditional model and comparing it like to new digital trends.
All right. Okay. There's another question there in the chat, Karen.
I think it was Leonardo.
Oh, was it?
No, there isn't. There isn't.
All right. Okay.
Okay.
So, okay. So we're gonna stop there by now and continue with Luis Ángel Márquez, who is going to talk about generation of Pareto front shape invariants, reference sets in multi-objective evolutionary algorithms. So are you ready, Luis Ángel? You can share your screen and start, please.
Yes, you can hear me?
Yes, we can. Yeah, thank you.
Yep.
You can see my presentation?
Yes.
Yep.
Okay, perfect. Okay, hello everyone, and thank you so much for attending this presentation. My name is Luis Márquez, and I'm going to present you my thesis topic entitled Generation of Pareto Front Shape Invariant Reference Sets in Multi-Objective Evolutionary Algorithms. The topics of this presentation, the agenda, will appear at the top of each slide. Well, first I'm going to explain some basic concepts. First, what is a multi-objective problem? Well, these problems involve the simultaneous optimization. In this presentation, we propose minimization problems of two or more objectives that are in conflict. This can be seen in the following figure. It can be seen a problem with two objectives that the minimization of one objective involves an increment in the other objective. The use of meta-heuristic algorithms like multi-objective evolutionary algorithms are useful to approximate the solutions of complex problems because they can generate multiple solutions in each run, and they do not require information on derivatives. In this figure, we can see a population of solutions where, for example, T solution has large values in both objectives, while T solution has a small value in the first objective, but it has a large value in the second objective. In order to determine the quality of different solutions, the Pareto dominance relation can be used. We can see that Y Pareto dominates C because it has smaller values in both objectives. X Pareto dominates Y because it has a smaller value in at least one objective, in this case, in the first objective. And W that Pareto dominates all other solutions. In a multi-objective problem, exists a decision space and an objective space. In the decision space, we have solutions represented by decision vectors. The evaluation of such solutions give us their image in the objective space, which are represented by objective vectors. The set of optimal solutions of a multi-objective problems is known as the Pareto set in the decision space, and its image in the objective space is known as the Pareto front, which is represented by this red line. In the objective space is where we can determine the Pareto dominance relations between solutions. In this example, the set of non-dominated solutions of the whole population represent an approximation set that aims to approximate the Pareto front. The general objective of MOEAs is to evolve a population of solutions to generate approximation sets with good convergence to the Pareto fronts and good distribution of solutions. In these figures, we can observe an approximation set with poor convergence and good distribution, an approximation set with good convergence but poor distribution of solutions, and an approximation set with good performance by converging to the Pareto front and distributing the solutions to fully cover the whole Pareto front. Here we can see the evolutionary process of two populations on two different problems. In the first case, we can see a population that is capable to represent in a good way the Pareto front. On the other hand, we have a population that converges to the Pareto front on specific points, but it is not capable to distribute the solution to fully cover the Pareto front. Some challenges for MOEAs include to obtain an invariant performance regardless of different Pareto front shapes, and to obtain a good performance on problems with 4 or more objectives. The MOEAs that use the Pareto dominant relations as selection mechanism, as main selection mechanism, have demonstrated a good performance on problems with 2 and 3 objectives. However, their performance degrades when dealing with problems that include more than 3 objectives. For those reasons, several strategies have been proposed to increase the performance of Pareto dominance-based MOEAs, as relaxed dominance-based, decomposition-based, indicator-based, or reference-based MOEAs. However, several MOEAs from these strategies require a reference set to decompose a multi-objective problem, to compute quality indicators that are used as selection mechanism, or to determine search directions into the objective space. The motivation for this research are the following. We have real-world problems that in real-world problems, it is common to find problems that have irregular Pareto front shapes and problems that have several objectives in conflict. The reference sets are required for some MOEAs to deal with this type of problems, and the performance of some reference set generation methods depend on the Pareto front shape. For those reasons, the main objective of my research is to design a mechanism capable to generate reference sets, which can be used by MOEAs to promote a good convergence and good distribution of solutions, regardless of the Pareto front shape. The quality in convergence and distribution can be measured by quality indicators. I talk a little about reference sets. The reference sets can be classified into 2 categories: real reference sets, which are generated with solutions found during the evolutionary process, and virtual reference sets, which are solutions composed by objective vectors that are generated in the objective space. A well-known mechanism to generate a virtual reference set is the generation of uniformly distributed points on a unit simplex. Some well-known MOEAs that use this virtual reference set are the MOEA based on decomposition, the NSGA3, and the RVA, among others. Here we can see the optimization process using NSGA3 on 2 problems with regular Pareto front shapes and 2 problems with irregular Pareto front shapes. We can see that the NSGA3 obtains a good performance and outstanding performance on problems with regular Pareto front shapes, while its performance is not so good. The distribution of solutions is not so good on problems with irregular Pareto front shapes. In order to increase the performance on problems with irregular Pareto front shapes, some reference set adaptation methods have been proposed. Some methods adapt the reference set based on solutions from the current populations, as the adaptive version of NSGA3 and the adaptive version of RVA, and other methods adapt the reference sets based on solutions preserved on an external archive, as the AR-MOEA. As current contributions of this research, a conference paper was published in the proceedings of the Conference on Evolutionary Computation of this year, and another conference paper was accepted for oral presentation and publication in the proceedings of the Mexican International Conference on Artificial Intelligence of this year. Next, I'm going to briefly describe each study. The first study is made in order to assess the performance of state-of-the-art reference set adaptation methods and to detect their main strengths and main drawbacks. This study is useful to give me information about the capabilities of different approaches to adapt reference sets. And for this assessment, we also propose a MOEA capable to use adaptive reference sets. For this assessment, we propose an IGD plus based MOEA, which is an indicator-based MOEA that uses the IGD plus indicator as selection mechanism. The IGD plus indicator measures the similarity between an approximation set and a reference set. 4 different versions of this MOEA are proposed. The first version uses the uniform reference set without any adaptation method, while the other 3 versions use the adaptation method from ANGA3, RBA star, and AR-MOEA. For this study, we include 7 problems from the DTLC test suite, and we also include the corresponding minus versions with 3 objectives. We also include all the problems from the IMOP test suite that include problems with 2 and 3 objectives. We can see the Pareto front shapes of some problems that are included in this study. Here we can see the ranks obtained by each MOEA in each problem based on the IGD plus indicator, which is used to assess convergence and distribution. The adaptation method from AR-MOEA is capable to maintain the good performance on problems with regular Pareto front shapes. While also we can see that all the MOEAs with adaptation methods increase the performance obtained by the MOEA without adaptation method on most problems with irregular Pareto front shapes. However, we can see that the adaptation method from AR-MOEA, from RBA star, obtains the best performance on most problems with inverted convex Pareto front shapes. In this table, we can see the ranks obtained by each MOEA with another indicator, which is the resistance energy indicator, which is used to assess the distribution of solutions. In general, we can see that the results show that the MOEA with adaptation method from RBA star and AR-MOEA obtained the best results. However, the MOEA with adaptation method from RBA star showed the best performance on all problems with irregular Pareto front shape from the IMOP test suite. In this figure, we can see the approximation sets of each MOEA on some problems. It can be seen that the MOEA with the adaptation method from ANGA3 and RBA star degenerate the good performance of the MOEA with adaptation method on problems with regular Pareto front shapes. While the MOEA with adaptation method from AR-MOEA maintains the good performance. Also, all the MOEAs with adaptation methods improve the performance in problems with irregular Pareto front shapes. We can see that the adaptation method from AR-MOEA have some difficulties regarding the distribution of solutions in some regions of inverted convex Pareto front shapes. Based on the results, we can conclude that the MOEA with adaptation method from AR-MOEA include the most balanced reference set adaptation method. However, it has some difficulties to achieve good distributions on problems with complex Pareto front shapes. Also, the selection mechanism used for this adaptation should promote diversity of solutions, and its performance should be invariant regardless of different Pareto front shapes. As we found that the selection mechanism used for the adaptation method from AR-MOEA have some difficulties on certain Pareto front shapes, the following study is made with the following objectives. We want to design a selection mechanism that promotes a Pareto front shape invariant performance. We want to combine the advantages of weight vector-based reference sets and the use of pair potential functions. Also, we want to perform an empirical study about the usage of 7 pair potential functions for this selection mechanism. The pair potential functions can be used as selection mechanism to select a subset of solutions with good distributions, regardless of the Pareto front shape. We select the following 7 pair potential functions to assess them for the proposed selection mechanism, and we include it into the NSGA tree. Our selection mechanism consists of an itching procedure and a pair potential selection. First, useful reference points are detected and the nearest solutions are selected. Then the remaining solutions are selected using pair potential selection to improve the distribution of solutions. On problems with regular Pareto front shape, all the solutions are selected using niching, while on problems with irregular Pareto front shapes, some solutions are selected using niching, and the rest of solutions are selected using the pair potential selection. In this way, the performance is maintained on problems with regular Pareto front shapes, while the performance is improved on irregular Pareto front shapes. And the distribution of solutions do not depend on the Pareto front shape. We include 7 problems from the DTLC test suite, and we also include the corresponding minus versions. In this case, we scale each problem up to 3, 5, 8, and 10 objectives. We can see the Pareto fronts of some problems included in this study with 3 and 10 objectives. Here we can see the summary of the results based on the hypervolume indicator, which is used to assess the convergence and distribution of solutions. It can be seen that all the proposed versions are capable to maintain the good performance on problems with regular Pareto front shapes. They maintain the good performance of NGA3, while on problems with irregular Pareto front shapes, the performance of NGA3 is improved. Also, we can see that the pair potential function of the Coulomb law permits maintaining the good performance on all problems with regular Pareto front shapes, while it improves on 36 problems out of 40 problems. Here we can see the approximation sets obtained by the proposed MOEAs. We can see that these MOEAs maintain the same distribution of solutions as NGA3 on problems with regular Pareto front shapes, while they enhance the distribution of solutions on problems with irregular Pareto front shapes. Similar results can be seen on problems with 10 objectives. Also, it can be seen here that the NGA3 is not capable to fully cover the whole Pareto front of the minus version of the DTLC1 problem with 10 objectives. However, with our proposed selection mechanism, it is possible to improve the coverage of the approximation sets. We can conclude from this study that all versions of NGA3K are capable to maintain the good performance of NGA3 on most problems with regular Pareto front shapes, while they significantly improve the performance of NGA3 on most problems with irregular Pareto front shapes. Also, the NGA3 with the pair potential function of Coulomb law obtained the best results on problems with regular and irregular Pareto front shapes. As current work, I'm working on a survey on reference set generation methods for multi-objective evolutionary algorithms to describe strengths and drawbacks of different reference set generation methods. And I am exploring the capability of our proposed selection mechanism to be used as a reference set adaptation method that promotes an invariant performance of MOEAs that require reference sets, which is the main objective of my doctoral proposal. These are some reference used in this presentation, and thank you so much for your attention.
Very good, Luis Ángel. Thank you. I don't know if we have any questions from the audience, students, professors. This is a more empirical, experimental, theoretical work. I have a question. You talk about in your motivation about real world problems. Is it your purpose, to test your methodology and not only, in benchmark problems, which is good because you compare against other algorithms, but once that you have the proper design of your algorithm and you say, well, this one works well in the benchmark set, what is your expectation for applying this to real world situations?
The real purpose of this research is to develop MOEAs capable to deal with different Pareto front shapes, because real problems are not well designed or beautiful designed as benchmark problems. They have highly irregular Pareto front shapes. For that reason, we want to create an algorithm capable to deal with different Pareto front shapes. as future work, we also want to test or mechanism for generating reference sets into real world applications, of course, that have irregular Pareto front shapes and many objectives.
All right. And just a comment about, you have two conference papers now, and then you're moving into the journal papers, right? I suppose that the survey and the other paper that you're working on the intention is to publish them in a journal paper, right? I suppose, because these are the requirements for the doctoral program, right? So you have to be aware of that.
The last two future works are intended to publish in journal paper.
Yeah, that's good. But the two previous works, they are good conferences, SEC and MCCi, right? Just to explore the initial ideas. Okay. Any more comments, by people in the audience? Edgar?
Ángel, as your supervisor, I'm kind of interested a little bit about when are you planning to finish those papers?
Well, we are currently work on the draft of such paper.
How is the paper going?
Well, the survey paper, we have already written some part of it. And the second future work that is the inclusion of our proposed selection mechanism into an adaptation method is the experimentation is almost ready, but we are going to start only with the writing process.
Okay. So hopefully by the end of this semester, having submitted, maybe?
One of them, at least.
Or the draft, maybe?
Yeah, I expected that at least we have draft ready.
Okay, perfect.
For the last of the semester.
Anyone else? Or we can also have questions for Karen.
I wanted to know if, Luis, if you have identified any particular real world problem that seems a good fit to your proposal.
Yes, I'm going to share again my screen. Can you see my screen?
Yes, I can see it.
Already exists some real problems that are tackled with MOEAs. For example, I have one here. This is why one problem about car design. This is a real problem that have irregular Pareto front shape, and it was a good candidate to use our reference adaptation method to see or to test how well it works on this type of problem. However, it exists so many problems, so many real world problems that have irregular Pareto front shapes. However, this is a good candidate because it's at least known the Pareto front shape as the real world problems do not have clearly the Pareto front shape. We need to see well or to detect problems that have at least some idea about their Pareto front shapes. But this can be a good candidate.
Okay, thank you.
Thank you so much.
No more questions? Well, I hope it's been a good exercise, for Karen and Luis Ángel, the presentation and the interaction and the preparation, because you have a limited amount of time, to do the presentation. So you have to, prepare when you do the presentation in a conference too, or in a different event, right? So that's good. So next week, we're gonna have 3 students from Estado de México. So we'll see you then. Thank you very much for.
Hugo, can I ask something?
Yeah, sure, of course, yeah.
As you saw from Luis Ángel presentation, there is one paper accepted for MCCi. I will ask you, Hugo, that we would like the Luis Ángel present its presentation for the conference in front of this public, so he can exercise how to present that into a conference. And that is an exercise that I've been looking to do with all my students. So maybe we can schedule something before Luis Ángel presentation in MCCi, so he can practice, and maybe all the students here and all the researchers can give us feedback and how to improve the speech of Luis Ángel and maybe the slides, because it's a good exercise for Luis Ángel to get involved and improve in that kind of venues like a conference.
Right, that's good. So you can schedule, the presentation, the practice presentation, and then let us know, and I can invite, people,
Perfect.
to attend.
Okay.
All right.
Excellent.
Okay, good. Yeah, it could be the academic coffee or something, we can schedule the event and just invite people, to come and try to give feedback, that's the important thing here, I suppose. Okay.
Thank you.
Yeah, no problem. Yeah, all right, because this could be good, for everyone, I suppose. Okay. So anyone else? Everything okay? Well, okay. Thank you very much for attending the seminar today. And so we're in the following weeks. I think we have almost scheduled the whole semester, for a weekly presentation. So I'll keep sending the invitations every Wednesday, for the seminar. Okay. So thank you very much. Pepe, everything okay? You want to mention something?
No, everything okay.
All right.
Right.
Good. Thank you then. Okay, we'll see you then, and keep safe.
Okay, thank you.
Okay, take care.
Thanks.
Thank you.
One.
Muchas gracias. Hasta luego.
Thank you.